Okay, now that we've looked at some specific functions, trig functions just recently, let's go back and look at functions in general and see once how they behave. First thing let's do is let's ask the question, if you have a particular function that you've graphed, and when you graph it, remember you always let y be the value of the function, then what happens if we look at these two functions as well? Suppose we multiply a function by a constant. Let's just let that constant be c. And also, what happens if we add two functions together? What happens to their graphs? Okay, it's pretty straightforward. You always have to be a little bit careful when a mathematician says straightforward, that they're not just being lazy, saying I don't want to explain it to you. But in this case, I think it is. Let's say that this, for example, is f right there. Say that's the function f. What happens if I take that f and I now graph the function of, let's be specific, let's say 3f of x. How's that going to change? Well, all that happens is you basically take this value right here, any value you want. Here's the value of x, and this is f of x right there. So there's the y value for this particular function. But now, for this one, we're going to do what? We're going to take f of x and then we multiply it by 3. So before we graph it, we take this value and multiply it by 3. So it's going to be 3 times as high. It's going to be up there. Take this value right here. What is f of x? Is this value, but before you graph this one, you multiply this height by 3, it's going to be 3 times as high. This one right here, there's the value of f of x. What does this say to do? It says to take whatever the value of f of x is, and you multiply it by 3, so it's going to be down there. So by the time you're done, if you multiply this by 3, it's kind of hard to do it exactly, but it's going to be what? 3 times as high, kind of like this. It's going to come down to 0 there, because 0 times 3 is 0. Go down 3 times, back up, something like that. So that would be 3 times f of x. You just exaggerate. Whatever this value is, this is 3 times as high. Okay? What happens if we add two functions together? So let's let g of x be this function, for example. Okay, there's the function g of x. What happens when we add those two together? Well, the same sort of thing. For every value of x, this is f of x, this is g of x. If you add this value and this value together, this height and this height, you're going to be up here someplace. Take this value of f, add it to this value for g, take those and you're going to be up here someplace. Take this value here, take that value there. By the time you add this negative one to whatever this one is, you're going to be down there someplace. So all the way through, you just take this value plus that value and add them together to get your new value. And if you did that, I tried to make something that would be kind of easy. Let's see. It's going to be basically this thing up higher and squiggling. And it's going to come down here, go underneath, go back, just very roughly like that. That would be f plus g. Okay, so that's the idea. A little bit more thought goes into what happens when we move functions around or kind of alter the function through translations and dilations. So let's take a particular function, and we're going to play with this one quite a bit. Here's our function. It's going to look like this. Right there. We'll assume that this is 3, this is 1, this height is 1, that's negative 1. Let's say that that's negative 1, and that's negative 2. So there's our function. given that that's our function, what happens if we do this, for example? What will y equal f of x plus 2 look like? Okay, what will that look like? Well, as I just explained, we basically are just adding two functions together. What we do is we say, okay, given this value of x, here's f of x. What does this one want us to do? It takes whatever f of x is and you add 2 to it, so you're going to be up here. For this value of x, here's f of x. What does this say to do? You add 2 to it, so you're going to be up here. And that's the new y value. For this value of x, here's f of x. You add 2 to it, you're going to be up here someplace. So by the time you're done, you're going to start here at 2, and you're going to basically go up, go down like that. This is at 3 again. This is going to go up to 3. This is 2. It's going to go down to 1. And this is, again, negative 2. So it's just going to translate the whole thing 2 units up when you take a function and add 2 to it. What happens if we take a function and we multiply it by 2? Well, same idea. Take this value of x. Here's what f of x is. Now we're going to multiply it by 2, so it's going to be twice as high. Whatever this value is, it says to multiply it by 2. So you take this value and you multiply it by 2. You're twice as high. What's the y value here? Here's x. There's f of x. What does this say to do? It says f of x, which is that value times 2. It's going to be down there. So everything here is going to be twice as far down. That one's going to be twice as up, twice as high. So it's going to look like this, roughly. Like so, where again this is 1, that's 3. Now it goes up to 2. It goes down to negative 2. And so on. Okay, it just exaggerates everything. How about this one? What does that do? Well, think it through. For any value of x, here's f of x. That's f of x, but I want my y to be the negative of that. So what's the negative of this height, of this value? It's down here. Here's the value of x. There's f of x. I want the negative of that. So it's going to be down here. Here's the value of x. There's f of x right there. I want the negative of that. The negative of a negative number is a positive number. So it's going to be up there. So this thing here is going to essentially just flip everything over the line. And don't get lazy. Don't try to remember the result. Instead, think it through like this. That's the way to do it. And there's your result. Okay, here's the last one I want to do. These are all things that come up in calculus from time to time. What happens if we take the absolute value? Well, again, what do? Here's x. There's f of x. What's the absolute value of this? This is a positive number. The absolute value of a positive number is just itself. So it stays just as it is. Here's a value right there. There's f of x. That's also positive. The absolute value of a positive number is positive, so it doesn't change it at all. Here's a particular value of x. There, f of x is negative. The absolute value of a negative number is the opposite of it, the negative of it. The negative of a negative number is positive, so basically everything that's negative becomes positive. So this is going to look like this. Okay, there you go. Now, those aren't too bad. These become more challenging. Watch what I'm going to do to each one of these. I'm going to get rid of this parentheses right there, and I'm going to put the 2 inside the parentheses. here I'm going to put the 2 inside the parentheses. I'm going to put the negative inside. And I'm going to put the absolute values inside. How does that change things? Let's get rid of all these now, because they're all going to be different, very different. With the previous ones, all we had to do was ask what happens to f, and then whatever happened to f, then we just altered it, okay? Now we have to revise our thinking a little bit. And here's the way I like to think about it. A lot of people now, when they're going to college or taking various higher education courses, one of the courses is something in cultural diversity or something like that, where the whole point of it is to try to see the world through someone else's eyes. And I tell my students, this is the mathematical equivalent of cultural diversity. You basically have to ask yourself, what does f see? You have to imagine yourself in f's place, in the place of the function, and ask what it sees. So here's the way I do it. I say to myself, when f sees a 0, this is what it does. First of all, it spits out a 0, and then it also creates a straight line on this side of 0, and it starts, it looks like an arc, or maybe a semicircular arc on the left side. That's what f does when it sees a 0. When f sees a 1, it at a peak like that. When f sees a 3, again it's down to 0 and it stops. When f sees a -2, it stops. Okay? So now I look at here and I have to ask, what do I have to stick in here for x so that f will see a 0? Well, that's not too hard to see. For f to see a 0, for there to be a 0 in here, x would have to be -2. So here I'm going to first of all redraw this just a little bit. I have a little more room. Okay, so here's -2 right there. When I stick in a -2, f will see a 0, and when f sees a 0, what does it do? It kind of starts this jobby. Okay, that's what it starts doing. Okay? What do I have to stick in here so that f will see a 1? I would have to stick a, what? A -1. -1 plus 2 is a 1. So here at -1, I'm going to be up there. And what do I have here? When f sees a 3, it comes to an end. What do I have to stick in here so that f will see a 3? 1 plus 2 is 3. So by the time I get to 1 over here, it stopped. What do I have to put in here so that f will see a -2? It comes, f comes to an end when it sees a -2. I guess I would have to put a -4 in here. So here's my -4 right there. This goes up to 1, down to -1, same as always. So you see what the effect of this was. It basically just moved the whole graph over 2 units. Now again, I caution you or encourage you, don't just remember to yourself, oh, when I have a plus there, I go to the left 2 places. No. You want to just understand it. So just understand it, just think about it, and you don't have to do as many points as I did. Once you do 1 or 2 of the points, when you realize all you've done is just translated the graph, then you can just translate the whole graph however many places you need. So the point is here, you start here and you just move the whole thing over 2 units and you're all set. Okay? If you had a -2 there, then let's just think about it a second. What would the graph look like? Now I say, oh, what do I have to put in here so that f will see a 0 again? and obviously you have to put a 2 in there. So you put a 2 in there, and then you just do something like that. Just translate it over 2 units. So that's the idea. Okay, what about this one? Tell you what, just to give a little more room, I'm going to bring each one of those up to the top here. And redo them up here. F of 2x. Okay? Same idea. You just go through this cultural diversity type thing and you ask, what does F see? So, the way to do it, when F sees a 0, it does this. If I stick a 0 in here, F will see a 0, so it's going to do it at exactly the same place. When F sees a 3, that's when it comes to an end. Agreed? When F sees a 3, that's when it comes to an end. What do I have to stick in here so that F will see a 3? Well, let's see. That means that 2x has to be 3, which means x has to be 3 halves. So by the time I get to 3 halves, F sees a 3 and it comes to an end. What do I have to put in here so that F will see a 1? When F sees a 1, it's at the top of the peak. I would have to put a 1/2 in here. So this is 1/2. When F sees a -1, it does this. What do I have to put in here so that F will see a -1? I'd have to put in a -1/2. -1/2 times 2 is a -1. And finally, when F sees a -2, it comes to an end. What do I have to put in here so that F will see a -2? I'd have to put in a -1. So right there. So basically, look at what happens. I hit the key points here. It's going to go up here. It's going to go down there. It's going to go like this. Here, this is -1 as before. This is 1 as before. All it did was it shrunk it. It shrunk it, compressed it, so that it did everything in half the space that this one did. Okay, so that's f of 2x. Okay, again, let's alter these just a little bit more. What if I had x divided by 2? How would that change things? If I had f divided by 2, then I ask, what here, when f sees a 3, it comes to an end. What do I have to stick in here so that f will see a 3? 6 over 2 is equal to 3. So I'd be all the way out to 6, and it would basically just move this whole thing so that now it expands the whole thing. Okay, it stretches it out. Okay, so that's that one. Okay, the advantage of taking Essentials of Calculus course as a video on a video is that for each one of these you can stop the video and try to think about it ahead of time. When I teach a class, I always give breaks for them to try to do it ahead of time, and now you have a natural opportunity to. So I encourage you, before I explain these next two, go ahead and see if you can figure them out on your own. Okay? So now let's going to do f of negative x. Okay? Well, see how good we're getting at our ability to see things from f's point of view. Okay, here's the way I like to think about it. When f sees positive numbers from 0 through 3, this is what it does. That's what it spits out. Those are the values that come out of f when it sees positive values from 0 to 3. When f sees negative values from 0 to -2, this is what it does. Okay? So now we're looking at this function. So I think about this. When I put in positive values here, f is going to see negative values. What does f do when it sees negative values? This is what it draws. So as I put in these positive values, f is going to see negative values, and as f sees negative values, it draws out this. Similarly, when I put in negative values here, the negative of a negative value is positive. See that again? These are already negative, so now x is negative. The negative of a negative is positive. What does f do when it sees positive values? It does this. So there you are. Like so. Okay, it just flips it over the y-axis. Okay? And finally, let's do this one. I've been teaching this material long enough that I know this one really challenges people. So again, go ahead and see if you can figure it out on your own. If you figure it out correctly, you're in the top 5% of all the students I've ever taught. Okay, maybe top 10%. Okay, at least on this particular problem. Okay, so let's assume you've taken time to do it. Let's think about it. So, first of all, here's what students sometimes do as a wrong answer. They do this, something like this, and I clearly say that's not a function to begin with, because a function, remember, any value that you stick in, you can only get one value out. I didn't mention when we talked about this before, there's something called the vertical line test. Any vertical line can only hit the graph of a function at one point at a time, because any value in the domain can only go to one value that it gets assigned to. So this obviously can't be the right answer, not if you have a function. So that's not right. So what is right? Well, let's go back to cultural diversity again, okay? So what do? We say to ourselves, when I throw in all these values here, these are all positive values, what happens when you take the absolute value of a positive number? It doesn't change it at all. So from f's point of view, it's just seeing f of x. It just looks like the regular old f of x. And what happens when f sees x? It just does this right here. So there you go. Okay, now let's do this one. You stick in all these negative values. Oh, x is negative, but the absolute value of a negative is positive. So f is seeing positive numbers. What does f do when it sees positive numbers? This tells you. When f sees positive numbers, that's what it does. Let me do that one more time. I throw in negative numbers, but before f even sees it, you're taking the absolute value of them. The absolute value of a negative is positive. And what does f do when it sees positive numbers? It does this. So there's what you get. Okay, so that's the great bunch of good problems there that explain how you can modify functions that you have, and we can use those on functions that we've already developed. For example, we know that we graphed this one earlier, absolute value of x looks like that. So what does this function look like? This function looks like this. So this function is going to, now just for sake of time, I'll do it a little bit faster and say that's going to shift it over 3 units, because when this function sees a 0, it comes to a sharp corner. What does this function what do you have to stick in here to see a 0? X would have to be 3, so it looks like that. And then if you want to, you can go, how about this thing plus 2? What does that do? Well, given any function, if you add 2 to it, that takes this y value and raises it 2 units. So it's going to look like this. And then if you want to, you can You can play with this as much as you want. Negative of that whole thing. What's that going to look like? Well, what does this say to do? Whatever the value this is, you take its opposite. So it's going to look something like that. You get that right there. So you can see how just by starting with one, you can get all sorts of other ones. Let's do a couple more examples like this, just to show you how it works. Okay, say I asked you to sketch the graph of y is equal to, let's say, negative x plus 1 quantity squared plus 5. Okay, what would you do there? Well, here's the way I start. I start by thinking, well, this is really the function I'm starting with is just the function x squared. X squared looks like this. Since x squared looks like this, what does x plus 1 squared look like? That's going to be shifted 1 to the right, or to the left rather, because I want this thing to be a 0 in here. So I have to put a negative 1, so that's what this looks like. Now what happens when I take the negative of that? The negative is going to be this. And then finally, what happens when I take that? And add 5 to it. It's going to shift it up 5 units. 1, 2, 3, 4, 5. Doing this quite quickly. Looks something like that. So there you go. Let's try one trig function as well, just to see how it works. What about y is equal to 5 times the sine of 2x? 5 times the sine of 2x. Okay. Oh, and let's make it even more interesting. Let's go absolute value of that. Okay, absolute value of that. Okay. So first of all, y equals sine of x. Recall that looks like this. Where it goes up to 1 and it starts over again at 2 pi. So if you have y equals sine of 2x, now I ask the question, where does the sine of x start over again? It starts over at 2 pi. What do I have to stick in here so that sine will see a 2 pi? I have to stick a pi in there. So it's going to start over again at pi. So here you are at pi. It does the whole up and down thing by the time it gets there, and then it just keeps doing that same thing over and over again. So again, it squeezes it. So this is pi right there now. Now what happens when you multiply that by 5? Well, what does this say to do? It says whatever number comes out of this one, what does it say to do? Before you graph it, you multiply it by 5. So instead of being up to 1, that's going to be 5. Instead of being negative 1, it's going to be negative 5. 0 will still be 0. So I'm going to have to cheat a little bit with my drawing. And now I'm going to say this is up 5 units rather than just 1 unit. Down to negative 5. And then finally, what happens when we take the absolute value? Well, the absolute value of any positive thing stays positive. The absolute value of any negative thing also becomes positive. So what's this going to look like? All the positive stays positive, but the negative also goes positive. Positive again, positive again. so on. This is still going to be pi right there. So that's pi, and this goes up to 5 again. There you go. So as I say, once you have the kind of these ways to modify functions, you can make all sorts of new ones, and not only can you figure out what someone else gives you, but if you're asked to do to say provide a landscape, say for a video game or something like that, and your landscape had to have a whole bunch of hills, you'd be able to figure out what to do, what to program into your computer in order to get a bunch of hills out. You'd be able to picture, oh yeah, well, if I start with a sine and make it rise as high as I want, I can make them as pressed together as I want, and I want them all to go up rather than having any go down, so I can take the absolute value. So once you understand these ideas, you can modify and kind of make your own pictures, which is very, very valuable when you're playing with functions. Okay, that's it.